T7.14. According to government data, 22% of American children under the age of 6 live in households with incomes less than the official poverty level. So 22%. A study of learning in early childhood chooses an SRS of 300 children from one state and finds that p hat, that is the sample proportion, is 0.29. Okay. All right, so from that paragraph there, I think we should go ahead and label the true proportion as 0.22 because that's coming from government data. And then we can label the sample size as 300 and the sample proportion as 0.29. All right, so just adding some labels to the information, the numbers in that paragraph. Part A, find the probability that at least 29% of the sample are from poverty level households, assuming that 22% of all children under the age of 6 in this state live in poverty level households. All right, so to answer part A, we need to use the sampling distribution of p hat. All right, so let's write something about its shape, its center, and its variability. All right, now what we know is that the shape is approximately normal. Here, let's write out the word approximately. If the product NP is at least 10 and the product N1 minus P is also at least 10. All right, in this case, remember N is 300, P is 0.22, so this is going to be 300 times 0.78, and both of those I'm sure are going to be at least 10. Like this is going to be 66. And the other one is going to be 234. Okay. All right, so we've confirmed that the sampling distribution will have an approximately normal shape. The center and variability, well, we can refer to our formula sheet to figure out those things. Okay. All right, so for p hat, right, its center is just going to be p, the true proportion, and the variability, as measured by the standard deviation, can be calculated by this square root expression. Okay. All right, so let's write this down. So the mean of p hat is just p, and that was 0.22. And the standard deviation of p hat is the square root of p, 1 minus p over n. So that'll be the square root of 0.22 times 0.78 divided by 300. And that is approximately 0.024. All right, so now that we're armed with that information, we can make a sketch here. All right, so this is a normal distribution with a mean of 0.22 and a standard deviation of 0.024. And we want to find the probability that the value is at least 0.29. Okay, so 0.29, shade the right tail. Okay. All right, so first let's write some notation. We want the probability that p hat is greater than 0.29. That's going to require us to standardize. So value minus mean over standard deviation. So 0.07 divided by 0.024, it's about 2.92. and then we'll look that up in table A. Okay, 2.92 is going to be right here, 9982. Of course, we have to subtract that from 1 since we're looking for the area in the right tail. So this is going to be 0.0018. Okay, very, very low probability. All right, part B. Based on your answer to part A, is there convincing evidence that the percentage of children under the age of 6 living in households with incomes less than the official poverty level in this state is greater than the national value of 22%? Explain your reasoning. Okay. Well, so based on our answer to part A, we see that it's very unlikely to get a value of 29% or higher purely by chance. Okay? Or in other words, we can think of this value as being statistically significant. Okay? In other words, we would say, yes, there is convincing evidence that the percentage in this state is greater than 22, because it's very unlikely that you would just get a value of 29% by chance. There must be some other reasons, and that other reason is probably that the state has greater poverty levels than the national value. Okay. All right, so let's summarize that. Okay, so we say yes, there is convincing evidence because it is unlikely that we'd get a value of 0.29 or greater purely by chance. Not that it's unlikely, but it's almost impossible, right? This probability is so close to 0. It's extremely unlikely. It's extremely